what I have here is a 2-stage reciprocating compressor out of an Infinity Carrier 4-ton air conditioner. So, it's an interesting little animal here. I had to rip it open. It's just the inquisitive little engineer in me. As you can see, I removed all the electrical components. There's usually the stator and the rotor, electrical windings all right here. You got your discharge line here and your suction line here. Discharge comes up and over and goes down here, and then the suction comes in up into the cap. But there's also a little silencer muffler right there. But what I found interesting is you pull this compressor, and I tore this all apart, of course, is that when you look at this, okay, now it's a 2-stage. It has 2 pistons. The pecker head here only has 3 wires. Okay, you run, start, and regular windings. But it's got 2 pistons. There's no oil pressure or solenoid or anything like that to tell it, hey, go to 2nd stage. The only thing it has is the motor and these 2 pistons. Now if you look closely on this piston, you've got this piece here that floats freely, seemingly. And it threw me for a bit of a loop because I didn't quite understand, as a background in diesel mechanics going to HVAC, how a piston is going to have a floating sleeve inside of it. Now this sleeve, it stops and hits this rest here on the cam, or the crank rather, and operates it. But this one is solidly connected like any other normal piston would be. So when you rotate it, it's going to go up and down. For every 1 revolution, it's going to go up and down 1 time. Okay? This one, however, when you rotate this crankshaft in this direction, you'll notice this piston goes up and down. This piston does not. It remains stationary for the most part. It's moving solely because I'm not rotating this at a constant RPM, and therefore this sleeve kind of moves a little bit, which makes it jiggle a little. Okay? But when I reverse rotation, there you go. That piston then starts to reciprocate, as well as this one, because it is completely connected. There's no crazy looking sleeve here. And now I have 2 pistons compressing the vapor refrigerant. Whereas when you go this direction, you only get 1. So when the crank is, or motor rather, is rotating the crank in this direction, you have 1 piston compressing gas, 1st stage. If I want to go to 2nd stage, I have to reverse rotation. Okay, and this has to happen within seconds. you know, because you don't want to stop it completely, let it rest, and then go into second stage, right? So it stops and then goes in the other direction. Hitting this sleeve, and now I'm compressing 2 separate pistons, which gives me a higher compression output. And try as I might, try as I may, I have not found any information on this operation. So, the search continues, but based on tearing this apart, it seems to be the only way that this would work. So it has to reverse the motor to go into second stage. Now, on a single phase motor, we know that they normally only will spin one direction. But you can reverse the rotation by switching the AC input. So somehow it tells this motor to go the other way. If I still had the electrical windings, there was a piece on it that actually looked like it might switch. The only thing about this compressor, or this Infinity AC, that I found different was that it had 2 separate contactors. ACs tend to have one contactor. You get an AC call, you know, 24 volts, closes the contactor, energizes the fan and compressor. Even a heat pump. The only difference is it energizes or de-energizes the reversing valve. The Infinity carrier systems here had 2 contactors, and the one contactor would energize for first stage, which would be rotation of the motor in this direction, which would be counterclockwise, looking at it from this direction. And then it would shift to second stage, which would cause the motor to then rotate clockwise, initiating both pistons. So that's interesting. Further research on my part is to be done on that, because I want to understand how they switch the rotation of that motor externally when the pecker head only has your 3 standard windings, run wires on there. See? So yeah, this compressor is fated to go to an air conditioning technician school and will be used to teach future technicians on how this works. Now, this technology is not new. It's this system was I want to say 10 years old, this AC that I tore out. I replaced it with another carrier Infinity system. I hope that they made some changes to how this actual compressor works. It's interesting, yes, but what I've found is that, and what some of the other techs I've talked to have found, is that the windings on the second stage that change it from counterclockwise to clockwise go bad. And something happens to where it seizes, or when I did tear this apart, this has a little play because I actually tore the seal out from right here. There was a some kind of plastic bearing inside of here at the end of the crank. I tore that out, so there's a little play. But as you notice, there's actually a little bit of play right here. That seems, I mean, you always have a little deflection, but that seemed a little, a little bit much. I don't know. But it also seemed that even with that bearing, that this motor was allowed to kind of drop down a little bit. And with the rotor right here, it actually caused a binding in the clockwise direction. Counterclockwise was fine. Clockwise seemed to bind, so not 100% sure. It's not a mechanical failure. I do believe it was a winding failure, possibly because the shift from clockwise to counterclockwise possibly overheated the windings. Again, I'm not sure, but this was a fun little project. You got your little relief right here on the discharge side. Pressure relief relieves the, if necessary, high pressure gas back into the low pressure side of the compressor. But yeah, so if you have more information on this, feel free to contact me. I really like to learn how things operate and why they operate, and tear things apart when I get the opportunity. Yeah, this is a fun little project. Anyway, I'm hoping to get more information on it. That way, when we do take it to the HVAC school, because our senior tech at the company I work with actually teaches there, he might know. So I may get that information from him, how this actually is supposed to work. They'll get a bird's eye view of how these work exactly, so that some of our future technicians, as the industry grows, hopefully will know a little bit more. But if you have any information on this, feel free to share. I would love to know. 2-stage, first stage, second stage, first stage. Anyway, signing off here. It's been a pleasure. Continue your education. If you aren't learning something every day, you aren't living. And that's kind of my motto. You don't understand something, figure it out. And that's what I'm trying to do with this. So I think I understand it. I just would like to confirm. So anyway, thanks again for watching. And yeah, you have a blessed day. Thank you. Bye.